All right, hello. Section 5.1 notes. Starting a new chapter now. This section of notes called perpendicular and angle bisectors. And it reads, when a point is the same distance from two or more points, the point is said to be equidistant from the objects. Triangle congruence theorems can be used to prove theorems about equidistant points. So the new vocab word, equidistance, it means the same distance from. On the next slide, here's some theorems for us. The first one, 511, perpendicular bisector theorem, which reads, if a point is on the perpendicular bisector of a segment, so I'm talking about point X, right here, that point right there, it's on the perpendicular bisector, then it is equidistant from the endpoints of the segments. In other words, that is congruent to that. 512, the next one, the converse. Converse means flip it around. This one reads, if a point is equidistant, in other words, we already have the tick marks, then it is on the perpendicular bisector. Then I can go ahead and mark these and mark my right angle. With that said, a locus is a set of points that satisfies a given condition. The perpendicular bisector of a segment can be defined as the locus of points in a plane that are equidistant from the endpoints of the segment. With that said, look at this example. Find each measure. I want to find the measure of MN. Well, if you look, you see tick mark, and the box. That means that this straight up and down is my perpendicular bisector, which means this side would equal that side because it's the perpendicular bisector. So this side over here would also be 2.6, and that would be my answer. From M to N would be 2.6. If you look at the next one, find each measure. Find BC. This time, I'm given 38 and 38, which means tick mark, tick mark. Since that's the case, I can go ahead and assume this is my perpendicular bisector. Right angle, so I can put a tick mark there and a tick mark there. Which means if this down here at the bottom is 12, this up here would be 12. But I'm asked to find BC. So from B to C would be 12 plus 12 put together. So my answer this time would be 24. Take a look at the next slide. Find each measure TU. So from T to U. Well, you see tick mark, and the box in the corner. So I can say this is that is definitely my perpendicular bisector, which the theorem says that this side then would be congruent to that side. So let's write that algebraically. 3x plus 9 equals 7x minus 17. Solve that. I would subtract 7x from both sides. That gives me negative 4x plus 9 is negative 17. Subtract 9 from both sides. Negative 4x would equal negative 26. Is my math here right? 17, yeah. Subtract 17. Divide by, just checking my math so I get a fraction here. When I divide by negative 4, x is going to be 13 halves, which is, what, 6.5, I guess. But that's not my final answer. I need to find this TU. Well, TU is way over here at 3x plus 9. So when I plug the 6.5 in, it's going to be 3 times 6.5 plus 9. That'd be what, 18, 19, 19.5 plus 9, which would be 28.5. Would be the length of TU, and that's what they're asking for there. Okay, that takes care of perpendicular bisectors. Let's go to the next page and talk now about angle bisectors. So we have two theorems here. Well, really there's one, then there's the converse of it. Let's start with the first one, the angle bisector theorem. It reads, if a point is on the angle bisector of an angle, so I'm talking about this point right here, C, then it is equidistant, meaning the same distance, from the sides of the angles. So I can put a tick mark there and a tick mark there. Notice the boxes in the corner. The converse of that says, if this point C, if I'm given the tick marks, that means this ray is the angle bisector. So I can go ahead and put these arc marks in there. So it goes both ways. That's the converse. So look at this example. Find the measure of BC. Well, I'm looking and I see this arc mark and that arc mark, which tells me this ray AC is my angle bisector. And the theorem then tells me I can put a tick mark there and a tick mark there. So if the bottom one is 7.2, that has to be 7.2. So BC is 7.2, which would be my answer. On the next one, find the measure of EFH. Given that EFG is 50. Well, I can see tick mark and tick mark. Well, according to the theorem, that means this is my angle bisector. So if EFG is 50, I would simply take 50 and divide it by 2. And that would be 25. And that would be the measure of angle EFH. That's what I'm asked to find. One more, and then we'll be done. Find the measure of MKL. Let's go over here and find MKL. I need that angle right there. Well, I can tell a tick mark and a tick mark. That tells me that I definitely have the angle bisector. So I could write this equation. 3a plus 20 equals 2a plus 26. And solve that. Subtract 2a from both sides. That gives me 1a plus 20 is 26. Then I would subtract 20 from both sides, and I would get a is 6. But hold on, that's not my answer. I need to find the measure of MKL. So MKL is this 2a plus 26. So I need to take this 2a plus 26 and plug my 6 into it. So 2 times 6 plus 26. Or 12 plus 26 is 38. And that would be the measure of that angle. So that takes care of perpendicular bisectors and angle bisectors. Thank you for watching.